Good morning students, welcome to all of you. Today we discussed about the next topics in the second lesson, laws of motion. In this we discussed today Newton's third law of motion, conservation of momentum, impulse. For that, first one, pulling two spring balances. Let us take two spring balances of equal calibration. Connect the two spring balances as shown in figure. Pull the spring balances in opposite direction. What do you observe, students? According to third law of motion, when an object exerts a force on the other object, the second object also exerts a force on the first one, which is equal in magnitude but opposite in direction. The two opposing forces are known as action and reaction pair. Newton's third law explains what happens when one object exerts a force on another object. If you are walking on the ground, at each step you know that your feet exert some force on the ground. That is the action. The ground also exerts some force in the opposite direction. That is the reaction. Now we discuss about the action and reaction forces. If two objects interact, the force FBA exerted by the object A on the object B is equal in magnitude and opposite in direction to the force FAB exerted by object B on the object A. That is FAB equal to minus FBA. The negative sign indicates that the reaction force is acting in a direction opposite to that of action force. This states that no single isolated force exists. When birds fly, they push the air downwards with their wings, and the air pushes back the bird in opposite upward direction. That is, the force applied by the wings of bird on air and an opposite force applied by the air on wings are equal in magnitude and opposite in direction. As well as when a fish swims in water, the fish pushes the water back and the water pushes the fish with equal force but opposite in direction. The force applied by the water makes the fish to move forward. That is, fish pushes the water is action, the water pushes the back to the fish is a reaction. Same, another example for the Newton's third law of motion. A rocket accelerates by expelling gases high velocity. That is the action. The reaction force of the gas on the rocket accelerates the rocket in a direction opposite to the expelled gases. This is also explained in another example. Activity, we understand the Newton's third law of motion. For this activity, we require simple items. One is balloon, second one is thread, straw, a small plaster. Now, first we inflate the balloon. Pass the thread into the balloon. Now, we place the balloon on the straw. Hold the straw. Now, we plaster the balloon and straw. Now, one end of the straw holds with your friend and the other end of the straw holds in your hand. Now we release the neck of the straw. Students, observe what happened. When we release the neck of the balloon, the air flows this side, the balloon moves that side. Now you observe carefully. I release the neck of the balloon. The balloon moves my left hand side. Air moves right hand side. That is action, reaction. The action is moving the balloon left hand side. The air is moving, reaction is moving the air into right hand side. This is each and every action has equal and opposite reaction. So by doing this simple activity, we easily understand the Newton's third law of motion. Students, You also do this activity at your home. In previous activity, we understand the action and reaction forces on single object, that is balloon. Now we understand the action and reaction forces on two different objects. For that, we take a glass bottle, we take a rubber cork. We pour some water in the glass bottle and place cork on the mouth of the glass bottle. Now tie a thread to the bottle, and now we heat this bottle on the stove for some time. Carefully observe what happened in the bottle or what happened in the cork. The cap moves forward, the bottle recoils back. That is, the cap moves forward is the reaction, the bottle recoils back is the action. Or the action is the cap moves forward is the action, the bottle moves back is the reaction. That is, the action and reaction forces acts on two different objects. Okay students, we discuss about the conservation of momentum. For that, we take two marbles. One marble has mass m1 and another marble has mass m2. These two marbles have two different velocities. First marble has velocity u1 and second marble has velocity u2. These two marbles are moving along the same directions with two different velocities. After collision, what happened? The first marble exerted a force F1 on the second marble. The second marble also exerted a force on the first marble. After collision, the velocities are changes. The velocity of the first marble changes from u1 to v1 and the second marble changes from u2 to v2. Now we calculate the momentum of these two marbles. Conservation of momentum. Law of conservation of momentum. First, we consider two marbles of mass m1 and another marble of mass m2. This u1, the second marble velocity is u2. When they are collide each other, they are changes velocities m1, m2, v1, v2. Now we look at the momentum of the marbles before collision and after collision. Marble 1, marble 2. Momentum before collision. Momentum before collision. Momentum. We already discussed about the momentum. Momentum is represented by the letter P. What is the formula? P equal to m into v. We consider the momentum for first marble. What is the mass of the first marble? m1. V. Velocity of the first marble? u1. That is the before collision. of the first marble momentum. What about the second marble before collision? Mass of the second marble m2 and velocity of the second marble is u2. Next, momentum after collision. In this case, what is the mass of the first marble? m1. What is the velocity? v1. What is the mass of the second marble? m2. What is the velocity? v2. Now, change in momentum. Change in momentum. Momentum means speed. That is before collision, after collision. What is the change? m1 v1 minus m1 u1. m2 v2 minus m2 u2. That is the change in velocity. After collision, it is the final velocity. It is the initial velocity. So change in velocity means final velocity minus initial velocity. That is final momentum minus initial momentum. Now, rate of change in momentum. Rate means in time, the change in time t. m1 v1 minus m1 u1 by t. This is m2 v2 minus m2 u2 by t. That is the force according to Newton's third law of motion. The force exerted by the first body on the second body is equal to the force exerted by the second body on the first body, but opposite in direction. It is written like this in the form of F12 equal to minus F21. That is, the force exerted by the first body on the second body is equal to the force exerted by the second body on the first body, but opposite in direction. Where the force is, according to Newton's second law, the force is change in momentum. The rate of change in momentum. F is equal to ma. Where the rate in change in, we already discussed what is the rate in change in momentum. m1 v1 minus m1 u1 by t equal to minus m2 v2 minus m2 u2 by t. T cancel. Now we write down remaining terms equal to minus m2 v2 minus into minus plus m2 u2. Now we bring down v1 terms in one side. m1 v1, the minus m2 v2 come this side, m2 plus m2 v2. m2 u2 minus m1 u1 becomes plus m1 u1. Therefore, we write down it m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That is the total momentum before collision of the first marble. The total momentum before collisions of two marbles is equal to the total momentum of the two marbles after collision. This is the law of conservation of momentum. Okay, student. A softer and more cushioned landing surface provides a greater stopping distance because of the longer time taken to stop. That's why the fielder pulls back his hands while catching a fast moving cricket ball. In this situation, the fielder is trying to increase the time to decrease its velocity. Thus, the rate of change of momentum will be less so that the force of impact of the ball on hands will be reduced. As we express the second law as F net equal to delta P by delta T. In order to minimize F net, we have to maximize the stopping time. That is F net delta T equal to delta P. From the above, we know that the product of net force and the interaction time is called impulse of net force. This activity, we understand the topic impulse. For this activity, we require what 2 eggs. Now we drop one egg from certain height on the cushion pillow. What do you observe? It jumps 2 or 3 times and it stops its motion. Is it break? No, it does not break. Why? Why? Because it is a cushion pillow, it is the soft surface. So it takes time to stop its movement. Now we take another egg. It does not consist any cushion, soft surface. We drop this egg from certain height. Now you observe what happened. It will broken. Why? Because it is the hard surface. That is, it takes less time to stop its motion and apply more force on the egg. So it breaks. That is the impulse. That is, it has the impulse is the it apply more force in less time. It applies less force in more time. So it does not break. The egg breaks in this case. Now we do a problem on the impulse. In textbook, it is the fourth question. Two people push a car for 3 seconds with a combined net force of 200 newtons. First one, calculate the impulse provided to the car. If the car has a mass of 1200 kgs, what will be its change in velocity? For first one, what value is given in the problem? For 3 seconds, that is time. Time is represented with the letter T. 3 seconds. With a combined net force. Net force means F net. Represented by the letter F. How much? 200 newtons. Which value we find out? Provided to the car. Impulse. Where impulse delta P equal to F net into delta T. What is the value of F net? 200. What is the value of time? T 3. That is 600 Newton second. Second one. If the car has a mass, in this case, given the mass of the car, where m is equal to 1200 kgs. And what will be its change in velocity? Mass of the car, m equal to 1200 kgs. Time, t equal to 3 seconds. Force, F net equal to 200 newtons. Now we find out change in velocity, that is delta V. We know According to Newton's second law of motion, what is the Newton's second law of motion? F equal to ma. Ma. What is A? Acceleration. What is acceleration? The rate of change of velocity is called acceleration. That is m into delta v by delta t. This is F. We find out the change in velocity. That is delta v. What is the value of F? 200 m. What is the value of m? 1200 kgs. Delta v by what is the value of time? 3 seconds. With 3, 400 times. Cancelling 1200. Now we find out the value of delta v. That is 200 by 400. That is 1 by 2 equal to delta v. That is delta v change in velocity is equal to 0.5 meter per second. Change in velocity is equal to 0.5 meter per second. Students, you also do this problem in your note. After watching this video, you will write the answers for the following questions. Explain Newton's third law of motion with one example. Second one is write the statement of law of conservation of momentum. Third one is define impulse and explain it. All of you write the answers for these questions and post your answers in your WhatsApp group. I hope you would utilize this topic in this way. Okay students, don't go outside without mask. Keep social distancing. Be safe, be healthy.